of ESSLCE Mathematics of the year 2013-2014 Ethiopian calendar. Let's move on. Question number 33. A factory that produced electric cable had a sales of 1 million in first day. During each successive day, the sales increased by 10,000. What's the total sales of the factory in the first 10 days? How can we approach this question? Let's first give a mathematical interpretation of this question. First day sales is equal to 1 million birr. Second day sales is equal to first day sales plus 10,000 birr. Third day sales is equal to second day sales plus 10,000 birr. If you follow this similar pattern, we will find that 10th day sales is equal to 9th day sales plus 10,000 birr. In general, the nth day sales greater than the preceding day sales by 10,000 birr. Thus, the constant 10,000 birr sales increment in each successive day is an indication that the sequence is an arithmetic sequence. The sum S sub n of the first n terms of an arithmetic sequence with common difference d is given by the formula S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 d, or S sub n is equal to n over 2 times a sub 1 plus a sub n, where a sub n is the nth term. The choice of which formula to be used depends upon the givens. So let's identify the givens. The first given is the sales of the first day, that is 1 million birr. The second given is the total number of days of which the sales to be calculated, that is 10 days. And the other given is the successive days sales increment, that is d is equal to 10,000 birr. So we are given all the unknowns of the first formula. Thus it's appropriate to use the first formula, that is S sub n is equal to n over 2 times 2a sub 1 plus n minus 1d. Plugging the givens to their appropriate function, we will find n is 10 divided by 2 times a sub 1 is 1 million plus n minus 1, that is 10 minus 1 times d, that's 10,000. 10 divided by 2 is 5 times 2 times 1 million is 2 million plus 10 minus 1 is 9 times 10,000, which is equal to 5 times 2 million plus 9 times 10,000 is 90,000, which give us 5 times 2 million plus 90,000, that's 2 million 90,000. 5 times 2 million 90,000 is equal to 10,450,000 birr. So choice B is the right answer. Question number 34. What is the least upper bound of the sequence 2 plus n over n plus 1 as n ranges from 1 up to infinity? Let's list some of the terms to understand the pattern of the sequence. If n is equal to 1, then 2 plus n over n plus 1 is equal to 2 plus 1 over 1 plus 1. 1 over 1 plus 1 is 1 over 2, thus 2 plus 1 over 2 is equal to 2 plus 1 over 2 means 0.5. So 2 plus 0.5 is equal to 2.5. If n is equal to 2, then 2 plus n over n plus 1 is equal to 2 plus 2 over 2 plus 1, which is equal to 2 plus 2 over 2 plus 1 is 3. Then this gives us 2 plus 2 over 3 is 0.666. 2 plus 0.666 is equal to 2.666. If n is equal to 24, then 2 plus n over n plus 1 is equal to 2 plus 24 over 24 plus 1, which is equal to 2 plus 24 over 25. This gives us 2 plus 24 over 25 is 0.96. Then 2 plus 0.96 is equal to 2.96. Let's add one more. If n is equal to 499, then 2 plus n over n plus 1 is equal to 2 plus 499 divided by 499 plus 1, which is equal to 2 plus 499 divided by 500. 499 divided by 500 is 0.998. So 2 plus 0.998 is equal to 2.998. From this sequence, we can figure out that 2 is constant, and as n approaches to infinity, n over n plus 1 approaches to 1, then 2 plus n over n plus 1 approaches to 3. Thus, the secant can be expressed as 2.5 less or equal to the sequence 2 plus n over n plus 1, which is less than 3. Meaning, this sequence is bounded from the left by 2.5 and values less than 2.5, and from the right by 3 and values greater than 3. 2.5 is the greatest of the lower bounds, and it's called greatest lower bound, and 3 is the smallest of the upper bounds, and is called the least upper bound. So the least upper bound of the given sequence is 3, thus choice A is the correct answer. Question number 35. Which of the following sequence is a null sequence? A sequence A sub n is a null sequence only when the limit of A sub n as n approaches to infinity is equal to 0. So let's check the limits of each of the given sequences. Choice A, limit of n over n plus 1 as n approaches to infinity is equal to, as we know, A is equal to 1 over A. Then, by the same logic, n over n plus 1 is equal to 1 the whole over 1 over n times n plus 1. Thus, the limit n over n plus 1 is equal to limit 1 the whole over 1 over n times n plus 1 as n approaches to infinity, which gives us limit 1 over n as the denominator has to multiply all the stuffs inside the bracket. Thus, 1 over n times n gives us 1. 1 over n times 1 is equal to 1 over n. As n approaches to infinity, 1 over n approaches to 0. So we left with 1 plus 0 as the denominator. 1 divided by 1 plus 0 is 1. 1 divided by 1 is equal to 1. So the limit of n over n plus 1 as n approaches to infinity is equal to 1. So sequence A is not a null sequence. Choice B, limit of cosine over n as n approaches to infinity. We know cosine function oscillates between -1 and 1. So both -1 and 1 approach to 0 as n approaches to infinity. Thus, limit of cosine over n as n approaches to infinity is equal to 0. Thus, sequence B is a null sequence. Choice C, limit of n sine 1 over n as n approaches to infinity is equal to, as we explained in choice A above, n can be rewritten as 1 the whole over 1 over n. So limit of n sine 1 over n is equal to limit of 1 the whole over 1 over n sine 1 over n as n approaches to infinity. Using the formula for division of limits, we can rewrite this equation as limit of sine 1 over n as n approaches to infinity divided by limit of 1 over n as n approaches to infinity. As n approaches to infinity, 1 over n approaches to 0, so sine 0 becomes 0 as the numerator. Again, as n approaches to infinity, 1 over n approaches to 0 as the denominator. 0 divided by 0 is undefined. In such case, it is recommended to find the limits of the derivative of both the numerator and the denominator. Thus, the derivative of sine 1 over n is equal to cos 1 over n times the derivative of the stuff inside, that is 1 over n, divided by the derivative of 1 over n. To calculate the derivative of 1 over n, simply rewrite 1 over n as n the power of -1. So using a power rule, the derivative of 1 over -1, 1 the power of -1 is equal to -1 times n the power of -1 minus 1. -1 minus 1 becomes -2. So -1 the power of n the power of -2. N the power of -2 can be rewritten as -1 over n squared. So the derivative of 1 over n becomes -1 over n squared. -1 over n squared cross out by -1 over n squared. So we left with limit cos 1 over n as n approaches to infinity. As n approaches to infinity, 1 over n approaches to 0. So cosine 0 is equal to 1. Choice C is not a null sequence. Choice D, limit 1 minus 1 over n as n approaches to infinity is equal to limit of 1 as n approaches to infinity minus limit of 1 over n as n approaches to infinity. Limit of 1 is 1. As n approaches to infinity, 1 over n approaches to 0. Limit of 0 is equal to 0. 1 minus 0 is equal to 1. So choice D is not a null sequence. The correct answer is choice B. Question number 36. Suppose A sub n and B sub n are sequence with limit of A sub n as n approaches to infinity is equal to L, and limit of B sub n as n approaches to infinity is equal to M. Then which one of the following is not necessarily true? Let's check each choice. A. Limit of A sub n over B sub n as n approaches to infinity is equal to limit of A sub n as n approaches to infinity divided by limit of B sub n as n approaches to infinity. This is the rule for division of limits. Limit of A sub n as n approaches to infinity is given as L divided by limit of B sub n as n approaches to infinity is equal to M. So the result gives L over M, provided that M is different from 0. Choice A failed to specify that M should be different from 0. Thus, choice A is not necessarily true. Choice B, limit of A sub n times B sub n as n approaches to infinity is equal to limit of A sub n as n approaches to infinity times limit of B sub n as n approaches to infinity. Limit of A sub n as n approaches to infinity is L times limit of B sub n as n approaches to infinity is M. So choice B is correct. Choice C, limit of 3A sub n plus 2B sub n as n approaches to infinity is equal to limit of 3A sub n as n approaches to infinity plus limit of 2 times B sub n as n approaches to infinity. 3 is a constant, so we can take it to the front. We'll get 3 times limit of A sub n as n approaches to infinity plus 2 is again a constant. We can take it to the front of the limit and we will find 2 times limit of B sub n as n approaches to infinity. This gives us 3 times limit of A sub n as n approaches to infinity is L plus 2 times limit of B sub n as n approaches to infinity is M. Then we will find 3L plus 2M. Choice C is also true. Choice D, limit of A sub n minus B sub n as n approaches to infinity is equal to limit of A sub n as n approaches to infinity minus limit of B sub n as n approaches to infinity, which is equal to L minus N. Choice D is also true. So the answer is choice A. Question number 37. Limit of 3x squared plus 2x divided by 5x minus x squared is equal to x is there in all terms of numerator and denominator. Thus, taking out x as a common factor, we will write the expression as limit of x times 3x squared divided by x is 3x plus 2x divided by x, the whole over x times 5x divided by x is 5 minus x squared divided by x is x, which is equal to x cross out by x, then we left with limit of 3x plus 2 as the numerator divided by 5 minus x as the denominator. Multiplying both the denominator and the numerator by 1 over x, we will find limit of 3x times 1 over x is 3 plus 2 times 1 over x, 2 over x, the whole over 5 times 1 over x is 5 over x minus x times 1 over x is 1. As x approaches to infinity, 2 over x approaches to 0, so we left with 3 as the numerator divided by, as x approaches to infinity, 5 over x approaches to 0, so we left with negative 1 as the denominator. 3 divided by negative 1 is equal to negative 3, so choice D is the correct answer. Question number 38. Which of the following is the same as the derivative of a function f at point P, where P is a graph of f? Geometrically, the derivative of a function can be interpreted as the slope of the graph of a function, or more specifically, as the slope of a tangent line at point P. So choice A is the right answer. Question number 39. What is the derivative of the function f of x is equal to 3x squared plus 2 root x minus 4x at x is equal to 1. The expression 3x squared plus 2 root x minus 4x can be rewritten in the form of a power function as 3x squared plus 2x to the power of 1 over 2 minus 4x to the power of 1. The formula for derivative of power function f of x is equal to ax to the power of n is equal to f derivative of x is equal to a times, taking n to the front, we will find n times x to the power of n minus 1. So the expression, which is presented as a sum and difference of the power function, can be differentiated as d by dx of 3x squared plus 2x to the power of 1 over 2 minus 4x to the power of 1 is equal to 3 times the derivative of x squared is 2x to the power of 2 minus 1 plus 2 times the derivative of x to the power of 1 over 2 is 1 over 2 times x to the power of 1 over 2 minus 1 minus 4 times the derivative of x to the power of 1 is 1 times x to the power of 1 minus 1. 3 times 2 is 6 times x to the power of 2 minus 1 is x to the power of 1, that's 6x, plus 2 times 1 over 2, 2 cross out by 2, we left with x, the power of 1 over 2 minus 1 is negative 1 over 2, minus 4 times 1 is 4, times x to the power of 1 minus 1 is 0, x to the power of 0 is 1, which is equal to 6x plus x to the power of minus 1 over 2 can be rewritten as 1 over x to the power of 1 over 2 minus 4. Substituting 1 in place of x, we will find 6 times 1 plus 4 times 1 to the power of 1 over 2 minus 4. This gives us 6 times 1 is 6 plus 1 divided by 1 to the power of 1 over 2 is 1 minus 4. 6 plus 1 is 7. 7 minus 4 is 3. So the correct answer is choice A. Question number 40. What are the second and the nth derivatives of the function f of x is equal to e to the power of 3x respectively? The derivative of f of x is equal to e to the power of 3x times the derivative of the power function, that is 3x, which is equal to the derivative of 3x is simply 3 times e to the power of 3x. E to the power of 3x means f of x, so 3 times e to the power of 3x is equal to 3 times f of x. The second derivative of x is equal to the derivative of the first derivative, which is equal to 3 times e to the power of 3x. 3 is a constant, so we can take it to the front, times the derivative of e to the power of 3x. The derivative of e to the power of 3x is already determined as 3 times e to the power of 3x. So 3 times e to the power of 3x is equal to 3 squared times e to the power of 3x, which means 3 squared times f of x. The third derivative of fx is equal to the derivative of second derivative, which is equal to 3 squared times e to the power of 3x. 3 squared is a constant that can be taken to the front, times the derivative of e to the power of 3x. The derivative of e to the power of 3x is already determined, so which is equal to 3 squared times 3 times e to the power of 3x. 3 squared times 3 is 3 cubed times e to the power of 3x, which is equal to 3 cubed times e to the power of 3x is f of x. Let's add one more. The fourth derivative of f of x is equal to the derivative of the third derivative of f of x, which is equal to 3 cubed times e to the power of 3x. E to the power of 3x is already known, which is 3 cubed times 3 times e to the power of 3x. 3 cubed times 3 is 3 to the power of 4 times e to the power of 3x, which is equal to 3 to the power of 4 times f of x. If we follow similar pattern, we will find that the nth derivative of f of x is equal to 3 to the power of n times f of x, because the n at the nth derivative is equal to n at the power of 3. So choice A is the right answer. Question number 41. Which of the following is true about zeros of a function? Graphically, the zeros of functions are points on the x-axis where the graph cuts the x-axis. Points where the graph cuts the x-axis are called x-intercepts. Hence, zeros of the functions are the x-intercepts of its graph. So choice D is the correct answer. Question number 42. Which of the following is true about the function defined as f of x is equal to x cubed minus 3x squared on the closed-bounded interval -1 up to 3? All the choices are talking about critical number. So let's define what critical numbers mean. Critical numbers are points where f derivative of x is equal to 0 or f derivative of x doesn't exist. F derivative of x is equal to 3x squared minus 6x, meaning the derivative of x cubed is 3x squared minus the derivative of 3 times x squared is 6x. The derivative of f of x is a polynomial function defined on all values of x, and its domain is already number, and is differentiable on all values of x. Hence, the critical numbers are those numbers where f derivative of x is equal to 0. F derivative of x is equal to 0, meaning 3x squared minus 6x is equal to 0. Taking out 3x as a common factor, we will find 3x squared divided by 3x is x, minus 6x divided by 3x is 2, which is equal to 0. This expression becomes 0 either when 3x is equal to 0 or x minus 2 is equal to 0. 3x is equal to 0 when x is equal to 0, or x minus 2 is equal to 0 when x is equal to 2. Now we have to check whether these numbers are on the specified interval or not. It's clear that both 0 and 2 are on the interval -1 up to 3. So both numbers are critical numbers. Critical numbers telling us about the local maximum and local minimum. In other words, f of critical number is equal to either local minimum or local maximum. So to compare the values of the critical number, f at 0 is equal to, just substitute 0 in place of x, we will find 0 cubed minus 3 times 0 squared. 0 cubed is 0, minus 3 times 0 squared is 0. 0 minus 0 is equal to 0. F at 2 is equal to 2 cubed minus 3 times 2 squared. 2 cubed is 8 minus 2 squared is 4 times 3 is 12. 8 minus 12 is equal to -4. 0 is greater than -4, hence 0 is the maximum on the given interval and -4 is the minimum. Choice A is the correct answer. Question number 43. What is the number that satisfies Rolle's theorem for f of x is equal to x squared minus 3x plus 1 on the closed bounded interval 0 up to 3? Rolle's theorem demands 3 requirements to be fulfilled. 1. A function has to be continuous on closed bounded interval a, b, and it should be differentiable on open bounded interval a, b. And third, f of a is equal to f of b. If all these 3 requirements are fulfilled, then there is a number c such that the derivative of f of c is equal to 0. The given function, that's f of x is equal to x squared minus 3x plus 1, is a polynomial function which is continuous on a closed bounded interval 0, 3 and differentiable on open bounded interval 0, 3, and f of 0 is equal to 1, which is equal to f of 3, meaning it fulfills all the 3 requirements of Rolle's theorem. Since the function fulfills all the 3 requirements of Rolle's theorem, we can calculate f derivative of c is equal to 0 on the closed bounded interval 0, 3. The derivative of f of x is equal to the derivative of x squared is 2x minus the derivative of 3x is 3 plus the derivative of 1 is 0 because the derivative of any constant is 0. Thus f derivative of x is equal to 2x minus 3. Let's calculate f derivative of c is equal to 0, simply substituting c in place of x at f derivative of x. We will find 2c minus 3 is equal to 0. Taking -3 to the other side of the equation, we will find 2c is equal to 3. Dividing both sides by 2, we will find c is equal to 3 over 2. So choice B is the correct answer. Question number 44. What are the lengths L and the width W of a rectangle with perimeter 10,000 meters that maximizes the area. Let's draw the picture of the rectangle like this. Perimeter is equal to twice of the length L plus twice of the width W, which is equal to 10,000. Multiplying both sides 1 over 2, we will find 12 times 1 over 2 gives L plus 2W times 1 over 2 gives W, which is equal to 10,000 times 1 over 2 is equal to 5,000. Without going for further calculation, we can realize that choice D is the answer, because it's only the sum of L and W at choice D is equal to 5,000. But for your general knowledge, let's go through the steps to solve the problem. For the purpose, let's write L in terms of W as L is equal to 5,000 minus W. We know the area of a rectangle is given by the formula A is equal to length L times width W. Substituting 5,000 minus W in place of L, we will find 5,000 minus W times W. Thus area is equal to 5,000 times W is 5,000 W minus W times W is W squared. We know a maximum is achieved at points where the derivative of a particular point is equal to 0, meaning the maximum area is achieved at a function defined as a derivative of A in terms of W is equal to 0. So the area function, that's 5,000 W minus W squared, has to be differentiated as the derivative of 5,000 W is equal to 5,000 minus the derivative of W squared is equal to 2W, which is equal to 0. Taking 2W to the other side of the equation, we will find 5,000 is equal to 2W, meaning W is equal to 2,500. Then L is equal to 5,000 minus W, which substituting 2,500 in place of W, we will find L is equal to 5,000 minus 2,500. 5,000 minus 2,500 is equal to 2,500. So choice D is the correct answer. Question number 45. If the radius R of a sphere is increasing at a rate of 2 cm per minute, then the rate of the change of volume when R is equal to 1 cm is. Let's first identify the givens. The givens are dr by dt is equal to 2 cm per minute and the radius is equal to 1 cm per minute. What's required is the change in the volume, or what's required is the rate of change in volume. Rate of change means derivation with respect to time, so we are required to calculate dv by dt. Volume of a sphere is calculated by using the formula V is equal to 4 over 3 pi r cube. Taking the derivative of both sides, we will find dv by dt is equal to d by dt of 4 over 3 pi r cube. Pi r cube is a constant, so we will take it to the front. We will find 4 over 3 pi times d by dt of r cube. The derivative of r cube becomes 3r squared times dr by dt. So 4 over 3 pi times 3r squared dr by dt is equal to 3 cross out by 3. We left with 4 pi times r squared times dr by dt. Plugging the value of r and dr by dt to their respective position, we will find dv by dt is equal to 4 pi times 1 centimeter squared times 2 centimeter per minute, which give us 4 times 2, which is equal to 8 pi centimeter cube per minute. So choice B is the correct answer. Question number 46. Which of the following equal to integral of cos x minus 2x dx, where c is a constant? A. Sin x minus x squared plus c. B. Minus sin x plus x squared plus c. C. Sin x plus x squared plus c. D. Minus sin x minus x squared plus c. Integral of cos x minus 2x dx is equal to integral of cos x dx minus integral of 2x dx. From the power rule, we know that integral of x the power of n dx is equal to x the power of n plus 1 over n plus 1 plus c. Hence, integral of cos x dx minus integral of 2x dx is equal to the integral of cos x is sin x minus 2 times integral of x, that is x the power of 1 plus 1 divided by 1 plus 1 plus c, which is equal to sin x minus 2 times x the power of 1 plus 1 is x squared divided by 1 plus 1 is 2 plus c. 2 cross out by 2, then we left with sin x minus x squared plus c. So choice A is the correct answer. Question number 47. What is the area of the region bounded by y is equal to 0 and the graph of y is equal to 4 minus x squared on the closed bounded interval -1 up to 1? Let's draw the graph of the region. Y is equal to 0 is simply the x-axis. To draw the graph of y is equal to 4 minus x squared, let's find the x-intercept and y-intercept. Y-intercept or x is equal to 0 is y is equal to 4 or the order pair 0, 4. X-intercept, that's y is equal to 0 or x is equal to 2 or order pair 2, 0 and x is equal to -2 or order pair -2, 0. Since the sign of x squared is negative, the graph or the parabola opens downward. Thus we have enough information to draw this graph. The graph looks like this. The region marked with a small box is the one whose area is to be calculated. The vertical lines, x is equal to 1 and x is equal to -1, meet with the graph of y is equal to 4 minus x squared at point -1, 3 and 1, 3. Thus, the shape of the region marked with small boxes is rectangular, as the region below the line y is equal to 3 and arc above the line y is equal to 3. In other words, the height of the shaded region at the y-axis is 4 and at the two edges is 3. It is impossible to calculate the area simply as integral of 4 minus x squared dx, where x ranging from -1 up to 1, because the graph of 4 minus x squared cut out this portion at the text and this portion at the right of the region bounded vertically by the line y is equal to 4 and y equal to 0, and horizontally by the line x equal to -1 and x is equal to 1. Such calculation is possible if we are asked to calculate the area between the graph of y is equal to 4 and y is equal to 0. So what can we do? We have a number of alternatives to approach this question. First, find the entire area of the region bounded between the graph y is equal to 4 minus x squared and y is equal to 0, and then subtract the unmarked regions at the left and at the right. The unmarked region at the left is equal to the unmarked region at the right, because if we fold the curve, y is equal to 4 minus x squared at y-axis, the two unmarked regions perfectly superimposed on each other. Thus, the area is calculated by using the formula as area is equal to integral of 4 minus x squared, where x ranging from -2 up to 2, minus integral of 4 minus x squared dx, where x ranging from 1 up to 2, then multiply this second integral by 2. One is representing the region, the unmarked region from -2 up to 1, and the other one is representing the unmarked region from 1 up to 2. We know that integral of a x the power of n, x ranging from a to b, is equal to a times x the power of n plus 1 over n plus 1, where x ranging from a to b, which is equal to f of b minus f of a. Using this formula, we can determine the area of the shaded regions, or the region marked with a small box. Integral of 4 minus x squared dx, x ranging from -2 to infinity, minus 2 times integral of 1 up to infinity times 4 minus x squared dx is equal to, the integral of 4 is 4x, minus integral of x squared is minus x squared plus 1 over 2 plus 1, where x ranging from negative to 2, minus 2 times, again integral of 4 is 4x, minus integral of x square is x square plus 1 over 2 plus 1, again x ranging from 1 up to 2, which give us 4x minus x the power of 2 plus 1 is 3 divided by 2 plus 1 is again 3, where x ranging from negative 2 up to 2, minus 2 times 4x minus x the power of 2 plus 1 is x cubed divided by 3, x ranging from 1 up to 2. So this first expression can be rewritten as 4 times 2 minus 2 cubed over 3 minus 4 times negative 2 minus 2 cubed, negative 2 cubed divided by 3, minus the second expression, that is 2 times 4 times 2 minus 2 cubed divided by 3 minus 4 times 1 minus 1 cubed over 3. 4 times 2 is 8 minus 2 cubed is 8 divided by 3 is 8 over 3 minus 4 times negative 2 is negative 8 minus negative 2 cubed is negative 8 divided by 3 minus 2 times 4 times 2 is 8 minus 2 cubed is 8 divided by 3 is 8 over 3 minus 4 times 1 is 4 minus 1 cubed is 1 divided by 3 is 1 over 3, which is equal to 8 minus 8 over 3. This negative has to multiply all the stuffs inside the bracket. So negative 1 times negative 8 is plus 8. Negative times negative 8 over 3 is plus 8 over 3. Negative 1 times 8 over 3 is negative 8 over 3. Minus 2 times 8 minus is 8 over 3 here. Again, this negative has to multiply the stuffs inside the bracket. That is negative 1 times 4 is negative 4. Negative 1 times negative 1 over 3 is plus 1 over 3, which is equal to 8 plus 8 in the first bracket is 16 minus negative 8 over 3 minus negative 8 over 3 is negative 16 over 3 minus 2 times 8 minus 4 is 4. Negative 8 over 3 plus 1 over 3 is negative 7 over 3, which is equal to make the denominator similar, let's rewrite all the expression in terms of some number divided by 3. Thus 16 is equal to 48 over 3 minus 16 over 3 as it is, minus 2 times 8 is 2 times 4 is 8. 8 means 24 over 3. Negative 2 times negative 7 over 3 is positive 14 over 3. 48 over 3 plus 14 over 3 is equal to 62 over 3. Negative 16 over 3 minus 24 over 3 is negative 40 over 3. 62 over 3 minus 40 over 3 is equal to 22 over 3. This is not the only method for solving this problem. As we can see from the graph, it's symmetric with respect to the y-axis. Thus, the area to the left of the y-axis is equal to the area to the right of the y-axis. Thus, we can calculate the area of either side and then multiply by 2. Hence, area under inquiry is equal to 2 times the integral of 4 minus x squared, x ranging from 0 to 2, minus integral of 4 minus x squared dx, x ranges from 1 up to 2, which is equal to 2 times integral of 4 is 4x minus integral of x squared is x squared plus 1 over 2 plus 1, x ranging from 0 to 2, minus integral of 4 is again 4x minus integral of x squared is x squared plus 1 divided by 2 plus 1, again x range from 1 up to 2, which is equal to 2 times 4x minus x the power of 2 plus 1 is x cubed divided by 2 plus 1 is 3, x range from 0 to 2 minus 4x minus x the power of 2 plus 1 is x cubed divided by 2 plus 1 is 3, x ranging from 1 up to 2. This first expression can be expressed as 2 times 4 times 2 minus 2 cube divided by 3 minus 4 times 0 minus 0 cube divided by 3 minus the second expression, that's 4 times 2 minus 2 cube divided by 3 minus 4 times 1 minus 1 cube over 3, which give us 2 times 4 times 2 is 8 minus 2 cube is 8 divided by 3 is 8 over 3 minus 4 times 0 is 0 minus 0 cube is 0 divided by 3 is 0 minus the second expression, 4 times 2 is 8 minus 2 cube is 8 divided by 3 is 8 over 3 minus 4 times 1 is 4 minus 1 cube is 1 divided by 3 is 1 over 3, which is equal to 2 times 8 minus 8 over 3. 0 minus 0 is 0, so minus 0 minus 8 minus is 8 over 3. This negative has to multiply all the stuff inside the bracket. This negative 1 times 4 is negative 4. Negative 1 times negative 1 over 3 is plus 1 over 3, which give us 2 times 8 minus is 8 over 3 minus, we have to simplify the expression inside the second bracket, that's 8 minus 4 is 4 minus 8 over 3 plus 1 over 3 is negative 7 over 3. Again, this negative multiply all the expressions inside the bracket, so we'll get 2 times 8 minus is 8 over 3, negative 1 times 4 is negative 4 times negative 1 times negative 7 over 3 is 7 over 3, which is equal to 2 times 8 minus 4 is 4 minus 8 over 3 plus 7 over 3 is negative 1 over 3. So let's make the denominator again similar. 4 means 12 over 3, so we will get 2 times 12 over 3 minus 1 over 3. 12 divided by 3 minus 1 divided by 3 is 11 over 3. So 2 times 11 over 3 is 22 over 3. Third method to calculate is just calculate the bottom rectangular region as 3 times 2 plus the upper arc region, which is calculated as integral of 4 minus x squared as x range from negative 1 up to 1 minus integral of 3 x ranging from negative 1 up to 1 x, because this region is bounded by the graph y is equal to 4 minus x squared and the graph of y is equal to 3. I will let this calculation for you. You will find similar answer, that's 22 over 3. So choice C is the correct answer. Question number 48. Suppose the integral of f of x dx, x range from 1 up to 3 is equal to 6, and the integral of f of x dx, x range from 1 up to 2 is equal to 10. What is the value of integral of f of x dx, x ranging from 2 up to 3? We know that integral of f of x dx, x ranging from 1 up to 3 is equal to integral of f of x dx, x ranging from 1 up to 2 plus integral of f of x dx, x ranging from 2 to 3. Integral of f of x dx, x ranging from 1 up to 3 is given as 6 is equal to integral of f of x dx, x ranging from 1 up to 2 is given as 10 plus integral of f of x dx, x ranging from 2 to 3. So taking 10 to the other side of the equation, we will find 6 minus 10 is equal to integral of f of x dx, x ranging from 2 to 3. 6 minus 10 is negative 4 is equal to integral of f of x dx, x ranging from 2 to 3. So choice D is the correct answer. Question number 49. Which of the following statements has a truth value of t? A statement is considered as having a truth value of t only when all the values are true. It's good to construct a truth value table for all alternatives to reply such questions. Then we will start the table by assigning the possible values for p and q. The possible values for p and q are p can be true and q true. P can be true and Q can be false. P can be false and Q can be true. P can be false, again Q can be false. These are the four possible values for P and Q. To solve for the first value, that's P or Q. P or Q is false only when both of them are false, otherwise it's true. So P or Q meaning true or true is equal to true, true or false is equal to true, false or true is equal to true, false or false is false. So let's find the second term of choice A, that is P and Q, or the conjunction. P and Q is true only when both of them are true, otherwise it's false. So true and true is true, true and false is false, false and true is false, false and false is false. P or Q implies P and Q, meaning the third column implies the fourth column. Implication is false only when the first value is true and the second value is false. Thus, true and true implies true is true, true implies false is false, true implies false is again false, false implies false is true. So choice A does have the truth value of T because we have false at the second and the third rows. Choice B, P implies Q implies P or Q. So before going to solve this function, let's determine P implies Q. As we discussed, P implies Q is false only when the first value is true, or the value of P is true and the value of Q is false. Then true implies true is true, true implies false is false, false implies true is true, false implies false is false. Then let's find P implies Q implies P or Q, meaning the sixth column implies the third column. True implies true is true, false implies true is true, true implies true is true, true implies false is false. So choice B not have the truth value of T because we have false at the fourth row. Choice C, P and Q implies P or Q, meaning fourth column implies third column. That is, true implies true is true, false implies true is true, false implies true is again true, false implies false is true. So choice C has the truth value of true because all the values in the column are true. Choice D, P and Q implies negation of P or Q. Before determining P and Q implies negation of P or Q, let's determine negation of P or Q. That is the negation of the third column. Negation of true is false, negation of true is again false, negation of true is false, negation of false is true. Thus, P and Q implies negation of P or Q, meaning the fourth column implies the ninth column. That is, true implies false is false, because implication is false only when the first value is true and the second value is false. Then false implies false is true, false implies false is true, false implies true is true. So choice D don't have a truth value of T because we have false at the first row. So the correct answer is choice C. Question number 50. The inverse of the function y is equal to 3x minus 5 is equal to A. Y is equal to x minus 5 divided by 3. B. Y is equal to negative 5x plus 3. C. Y is equal to x plus 5 over 3. D. Y is equal to x plus 3 over 5. Follow the following steps to solve this problem. First, switch x and y, meaning write y in place of x and x in place of y. Then x is equal to 3y minus 5. Second, write y in terms of x. Taking negative 5 to the other side of the equation, we will find x plus 5 is equal to 3y. Multiply both sides by 1 over 3. Then x plus 5 times 1 over 3 is equal to x plus 5 over 3. 3y times 1 over 3 is equal to y. So the inverse of the function becomes y is equal to x plus 5 over 3. So choice C is the answer. That's all for this episode. The remaining 15 questions will be solved in the next lesson. Don't forget to subscribe, like and share this page. Goodbye.